This is Professor Derek Seitz. This Java tutorial is part 3 and the last on exceptions. This is called exceptions contained. We have a calculator example. This is the class diagram showing the class hierarchy. We have a calculator class, a calculation expression class, and a client class that manages and exercises the calculator. A calculation expression, as the comment shows here, is operand 1 followed by an operator and operand 2. And the operator can be a plus for addition, subtraction is a minus, star for multiplication, slash for division, and there's two other kinds of division operators in this calculator. A slash little e is a division with an exception that's thrown, and a slash with a little v is a division with validation. The calculator has add, subtract, multiply, divide, divide with exception, and divide with validation functions. And the expression class allows you to instantiate it with a string and get the operands, or get the operator, and to check if it's valid or not. And internally it uses a private member here, parse expression, and you can also set the expression without actually using this constructor. There's a default constructor as well, and you can set the expression with a string. Let's look at the code for these classes now. Here is the code for the calculation expression class. Has the comments up there showing the form of an expression, the operator, the operands on either side. It has some integer public static finals that have keywords that can be used for the operator. It's an alternate to an enum. Then it has the private data, the operator, the two operands, a boolean, whether it's valid or not, and the actual expression. You can give it a string into the constructor here, and there's a default constructor as well. You can get the operand 1 or 2, get the operator. There's a isValid to determine whether it's a valid expression or not, and then the parse to determine whether it's valid. Here's the code for it, and what's of interest in here is the try and catch keywords. Here we're going to have a scanner that's going to take the expression, so the scanner will be tied to a string which has our calculation expression, and it will try to parse that to get out a double as the operand 1, a string as the operator, and then another double as operand 2. But it will handle some possibilities of input mismatch exception and a no such element exception. So here's the try statement and the try block right here, this code to manage for exceptions. And if an exception occurs, the exceptions that will be handled here are the input mismatch exception, no such element exception, and when there is an exception, the isValid will be set to false. Down here, if everything goes okay, it cases out on the operator that it got and sets the variables that are convenience variables to refer to the operator by convenience constant names. And finally, if everything's good, it sets the internal boolean to true. There's a private function here to reset all the parts to an invalid values, including not a numbers for the operands. And set expression down here calls parse expression, and the constructor up here as well also calls parse expression. So this is the calculation expression. Let's look at the calculator next. The calculator right here has the add, divide, divide with exception, divide with validation, multiply and subtract. Add is what you would expect. Takes two doubles, returns a double, adds them. Divide, divides without any kind of checking or anything. Divide with exception checks if the denominator is equal to 0. It will actually throw an arithmetic exception saying division by 0, and then it has to declare, specify that it throws that exception. Divide with validation takes a different approach. It checks if the denominator is 0, and it doesn't throw any exception. Instead, it's going to return not a number for the result. So that is a valid double. This is a way to avoid the overhead of exception handling. Whenever possible, to use alternative simpler methods should be considered, such as validations and special values. It's a trade-off that has to be considered, the pros and cons. Multiply is straightforward and subtract is straightforward. So that's our calculator class. Now we'll look at the client that manages this. The client, here's the main function. We have a string, an array of strings. Here are the calculation expressions we're going to try in this example. We have some like 1 plus 2 and 100 minus 75, some good ones, and we have some ones that are going to cause problems because they're not valid, like a plus b. There's a divide by 0. There's a divide by 0 with exception. There's a divide by 0 with validation. Down here, there's not a second operand. Down here, there's not an operator. Here, there's neither operand nor operator. So we're going to exercise it on this array of calculation expressions. What we do is we instantiate a calculator called calculator here, and then we get a calculation expression instantiated called calculation expression. We use an enhanced for loop to go through the array, and each element's called expression. We then set the expression into the calculation expression and then check to see if it's valid with its isValid function. If it's not valid, we print out that it's invalid, we print a space line, and we continue processing the array. If it is valid, we go ahead and get the operator and the two operands from the calculation expression. We define the result and initialize it to not a number, and then we switch on the operator using the convenience constants and call our calculator, passing in the operands and getting the result back. In here we also have a try block. In here, when we call the divide exception, with exception, we know it's going to be throwing possibly a arithmetic exception for divide by 0. So we take our code and put it in a try block and with a catch handler for the arithmetic exception. And if we get it, we say we caught it, and we print out the message that was returned from it, and then set our result to be not a number for that case. Divide, validate, we don't need any exception handler. And finally, we print the expression and the result. We're now going to run the program and see what it does. Running it. Here's the output. It's taking each one of the calculation expressions and processing it. 1 plus 2 is 3. Remember, we're dealing with doubles here. Even though we put some integers in, we're treating everything as a double. 100 minus 75, 7 times 3.14, everything's going good here. 1 divided by 0, we get infinity, which is the result there of that one. When we do double divide by 0, it does not throw an exception, it sets the answer to infinity. Here we did division by 0 with the throw an exception, and it caught the arithmetic exception. Here we do the validation divide by 0. We get back not a number on both of those. And then looking down here, the a plus b, is an invalid expression, and we caught the exception there. That's displayed out. Here we have one add one that's also invalid. There was no exception thrown on that. We determined that in our switch statement. On the operator, there was no AND operator. A plus is invalid, A is invalid, a space is invalid, and a null string is invalid. So again, we see here that we're able to allow the program to handle the normal cases and gracefully not blow up, but to be able to detect the invalid expressions and even print out which ones it got that were invalid. So this shows the value of having these managed try-catch blocks that allow us to run a program and not have it blow up to crash on us if we can carefully manage it.